This is section 3.1 in your class notes on page 1, and we're looking at exponential functions. I'd like to first of all define exponential functions. It's of the form y is equal to a raised to the x power, where you call a as the base, and it is greater than 0, and it cannot equal 1. The exponent is all real numbers. So from back in algebra, we're going to do a quick review of the law of exponents. And we're going to let S, T, A, and B are real numbers. And A is greater than 0, and also B is greater than 0. So if you have the base A, raise it to the S power times A raised to the T power, then the exponents get added together with the same base. So that would be equivalent to a raised to the s plus t. If you take a power of s and raise it to another power, then you multiply the two together. So it'll be a to the st. If you have a, b quantity raised to the s power, then you can rewrite it as a to the s times b to the s. 1 raised to any power is equal to 1. And a raised to a negative power will reciprocate it, so it's 1 over a to the s. And a to the 0 power is equal to 1. Okay, let's look at some facts about graphs of exponential functions, and it's of the form a equals a to the x. The domain is all real numbers. The range is y is greater than 0, and the x-intercept is none. So I'm just going to do a graph, and we're going to assign the base of 2 for a, so it'll be f of x is equal to 2 to the x. And so I've written out a truth table on the side. So when x is equal to 0, you have 2 to the 0 power, which is equal to 1. And then when x is equal to 1, it'll be 2 to the first power, which is 2. And when x is equal to negative 1, it's 2 to the negative 1 power, which is equal to a half. So I've plotted those 3 points. So I have 0, 1, 1, 2, and negative 1, a half. And then you have your exponential graph. Okay, so the y-intercept is at 0, 1. And there's also a horizontal asymptote, not all the way through at y is equal to 0, but as x goes towards a negative infinity. So if you look at this right here, I put a dotted line over to the left. So if I extended this, it would ride along the horizontal asymptote. The other characteristic is that this is an increasing function, which is 1 to 1. And there are 3 key points on the graph. At 0, it's 1. At 1, it's going to be whatever the base is. And at negative 1, it'll be 1 over whatever the base is. And the graph of f is smooth and continuous, which means it also has no corners or no gaps. Okay, the next graph I'd like to look at is when you have an x that is a negative power, so y is equal to a raised to the negative x, and you can rewrite this as y is equal to 1 over a and then raised to the x power. Oh, there's one thing I wanted to comment about the previous one. This is called an exponential growth. So if you could write that in at the bottom there. All right, so then going on to the next one, here's my truth table, and I'm going to look at it as f of x is equal to 1 half raised to the x power. So when it's 0, it's 1. When it's 1, it's going to be a half. When it's 2, it's 1/4. And when it's a negative 1, it's going to be 2. So I'll plot those points. And those points are at 0, 1. 1, it's a half. 2, it's a fourth. And at negative 1, it goes up to 2. And I can also plot in negative 2, it's going to go up to a 4. Right? So then you're going to draw this out. And this is called an exponential decay. Right, so the domain is all real numbers. The range is y is greater than 0, and there are no x-intercepts. The y-intercept is at 0, 1, so that's right here. And there's a horizontal asymptote, and this time it's as x gets closer to infinity, so it's along the right side right here. So when you have a 1 over a form, it is decreasing. Okay, so the slope is negative, and then it's a 1-to-1 function. And the graph of f, it contains the point 0, 1, 1, and then 1 over a, or whatever the base is, and then negative 1a. And the graph of f is smooth, and it's also continuous. Okay, we're going to go on to the next page, page 2. Okay, so there is a very important base that's going to be coming up, and the base is E, and this is called the Euler number, right? It's pronounced like Oiler, not Euler, but Euler. It's also referred to as little e or the natural number. In calculus, this expression is e is approximately the limit, and then it's 1 plus 1 over n raised to the n power as n goes out to infinity. Okay, so it's actually an irrational number, just like pi, and it's approximately 2.7. And if you wanted to know the other decimals, it's 1828, 18284, or 549. And so you just need to know that its E is approximately 2.7. Okay, so when I graph this out, e to the x is going to lie in between 2 to the x and 3 to the x. Right, so I've just plotted them out. So I'm first going to show you 2 to the x. So at 0, it's going to be 1, and that's a common point for all three of them. And so I'm looking at the purple graph here. So at 1, it's going to be 2, and then at negative 1, it's going to be a half. And then for 3 to the x, at 1, it's going to be 3. So this is the blue graph. And then at negative 1, it's going to be a third. And so that means that for e, it's going to be at 1, it'll be e, which is about 2.7. So see how it's right in between. And then for negative 1, it's going to be right in between there, which is about 1 over 2.7. Right? So the graph of e to the x, it lies in between the graphs of 2 to the x and 3 to the x. Okay, so the next thing I want to do is to go through some transformations using the things that we have just talked about. So let's go over problem A. All right, so the instruction, it says graphing using transformations. Describe the transformation in words, then find the domain, the range, and then the horizontal asymptote. Okay, so I'm going to first of all look at the parent function to be f of x is equal to 3 raised to the x power. Okay, so let me write that down. So the parent function is y equals 3 to the x. Right, so then the things that are going to change on this is the negative here will make it so that it is an x-axis reflection. And then this is the same thing as saying 1/2 x in the power. So this will be a horizontal stretch of 2. and then the plus 1 makes it go up 1. So I'm going to write this out as a mapping. So if the original parent function has the point that is x comma y, then the x-axis reflection changes the sign on the y, so it's minus y here. The horizontal stretch of 2 will make the x value become a 2x, and then the up 1 will make it so that it's negative y plus 1. All right, so I'm going to take the key values of 3 to the x, and then I'm going to apply this transformation on it. So I draw out a truth table, and I put on the left column x, y, and then on the right, I'll just write out what this mapping is, 2x comma negative y plus 1. So my 1 point on the parent function is 0, 1. Another one is 1, 3, and then a negative 1, 1/3. Right? So I write those 3 points out first. And then I just apply this transformation. So 2x means that I'm going to just multiply this x by 2, so that'll just keep it at 0. And then for the y, I negate the y, and then I add 1, so that'll become 0. Okay, so you're going to apply that to every single one of them. And so the next point will become 2, negative 2. And the next point will become a negative 2, 2/3. All right, then you plot these points out. So I have a point at 0, 0, at 2, negative 2, and at negative 2, 2/3. Okay, so now I'm going to read off the information at the very bottom. So first of all, the domain is all reals, and it's going to be all reals for all of the exponential. And the range relates to the horizontal or the vertical shift right up here. Okay, so see how it says a plus 1? So it's used to be y is greater than 0 in the parent function, but since I have a vertical translation of up 1, it's going to be y and then a 1. And then the x-axis reflection makes it so that it's less than instead of greater than. And the range and the horizontal asymptote are closely related. So it's going to be y is equal to 1, and it's as x goes out to a negative infinity. Right? So I've drawn that in a dotted line. Okay, let's try another problem. So for this one, I'm going to rewrite it as 3 and raise it to a. I'm going to factor out a negative, so it'll be a negative quantity x minus 2, and then a minus 4. Okay, so first of all, you have a y-axis reflection, which will be this from this, power of a negative. And then it's going to go right 2, so that's this part right here. And then down 4, so it's minus 4 from this. So my mapping is xy maps onto y-axis reflection negates the x, and then you're going right 2, so it's plus 2, and then you're going down 4, so it's going to affect the y, which is y minus 4. Okay, so I draw out my truth table, and my original is the same as what I had over in example A. So xy, I have 0, 1, 1, 3, negative 1, 1/3, and then I apply this mapping. So negative x plus 2, so it'll be 0 and then a plus 2, so that it'll give me a 2. For the y, I take this point, 1, 1 minus 4, and that gives me a negative 3. Okay, so I'm going to use the same rule for these 2 points. So this will give me a negative 1 plus 2, which is positive 1. And then a 3 minus 4, which gives me a negative 1. And then the last point is 3 and a negative 3 and 2/3. Okay, so I'm going to plot out these points. And so it's going to be 2, negative 3. There's my 1 point. 1, negative 1. And 3, negative 3 and 2/3. Okay, so my domain is all reals. The range is y is greater than a negative 4. Right, so again, the vertical translation is affecting this number, is affecting the range. And then since I don't have a x-axis reflection, it still stays as greater than. So y is greater than a negative 4. And then the horizontal asymptote matches up with the range in terms of the numbers. So it'll be y is equal to a negative 4, and it's as x approaches positive infinity. Okay, I'd like you to now try the next two problems. So if you could go to page 3 and turn off the video, and I'd like you to try C and D, and then come back and check your answers. All right, here's the solution for C. So for this one, I'm going to rewrite it. The 1/3 power, or 1/3 of a base, I'm going to rewrite it as 3 to the negative 1. So when you take a power to a power, it's a negative 2x. So it's 4 times 3 raised to the 2x. And so this is the main one that I'm going to be looking at. So the 4 out in front gives it a vertical stretch of 4. The power makes it as a horizontal shrink of a half. So my mapping is xy goes to 1/2 x because of the horizontal shrink of a half. And then my vertical stretch of 4 is 4y. Okay, so I make out my truth table. So xy is 0, 1, 1, 3, and negative 1, 1/3. And then I apply 1/2 x and 4y, so it'll become 0, 4, 1/2, 12. Right, so to all the x's I'm multiplying by a half, and to all the y's I'm multiplying by 4. And then my last point is a negative 1/2, 4/3. Okay, so then when I graph it, I get this graph here. And then here is the horizontal asymptote. Okay, and then the domain and the range on that. The domain is all real numbers, and then the range is y is greater than 0. So there's no vertical translation, so it's just going to stay at 0. And then the horizontal asymptote is y is equal to 0 as x approaches a negative infinity. Okay, for the next one, you may have to use your calculator on this one in order to estimate the values, because e is not a nice number. So first of all, I'll rewrite it so that it is negative 3 times e raised to the x plus 2. And then this 1 here, I'm going to bring it off to the right side as a plus 1. Okay, so there's 4 transformations that's going on here. First of all, there's an x-axis reflection from this. There's a vertical stretch of 3 from this. I'm going left 2 from the power here, x plus 2. And then I'm going up 1 because of this. Okay, so the mapping is xy goes to x, and then I have a minus 2, so that's from the left 2. And x-axis reflection negates the y, so it's a minus. And then there's a vertical stretch of 3, so it's a negative 3y. And then it's going to go up 1, so it's a plus 1. Okay, so my 3 key points I have is for the parent function. So this time the parent function is e to the x. So it'll be at 0, 1, 1e, and negative 1, 1 over e. And then if I apply this transformation to each of these points, I have 0 minus 2, so it's negative 2. And then for the y, it's a negative 2. For the next point, it's negative 1. And then I just use my calculator on this one. Right, so I'm just taking a negative 3e plus 1. That's what this is. Negative 3e plus 1. So that's a negative 7.15. And then 1 over e times a negative 3 plus 1, that gives me a negative 0.104. Okay, so I plot those points on here, and this is the graph that I get. So the domain is all reals, and then the range is y is less than 1. Right, so this is the vertical shift, so, and then it's a x-axis reflection. And so the horizontal asymptote is y is equal to 1 as x approaches a negative infinity.